Perfect. So yeah, today's meant to be kind of like an intro to, I would say, like Solidity and smart contracts. If you're thinking about becoming a Web3 developer, or looking into it, curious about how to start, um, this should be a sort of fun little thing to do. I recommend you guys to follow along if you can, if you have your computers with you, try to follow along. And if you can't, that's okay. We'll have a recording that will go out afterwards, so you can follow along then. But today, we're going to be building a tax token on Ethereum. I'm going to tell you what it means. We'll get into it. Yeah, let's just go through that. So a little bit about me. Fahim already introduced me, but hi, I'm Hardik. I have no first name. The co-founder of Learn Web3. I'm a huge maxi for sort of education and decentralized ID these days. Ex-Waterloo student, ex-Dapper Labs, ex-Ceramic Network, yada, 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 whatever. You can reach out to me on Twitter or Discord. It's linked there. I'll share this presentation at the end if you have any questions or anything at all. And yeah, so let's kind of get started. Today we're going to kind of understand what I mean when I say tax token. I'll spend a few minutes on that. Then we're going to spend some time coding. That's where I suggest you try to follow along if possible, and we'll leave some room for Q&As and buffer time in the middle as well. If you have sort of any questions, don't necessarily wait until the end. If you want to talk and like discuss something, maybe wait until the end. But if you just have any questions about something I'm saying or something I'm going through, I have an eye on the chat, post it in chat, and I'll try to answer it live. So yeah, that being said, let's get started. So what is a tax token? First of all, I'm not going to lie, it's kind of a Ponzi scheme. So maybe not a legit project you should try to build, but it's still an interesting and a fun project to start learning if you're new, because I kind of think like if you're not having fun when you're learning something new, you probably, it's hard to dedicate time to that. So it's kind of a Ponzi scheme. It's not it's not like the most morally ethical thing to do. On the right is the logo for SafeMoon. I don't know if you've ever heard of it. Massive Ponzi token. But the way I intend this to be, and the way I think you should be looking at this, is kind of use this as a way to understand Solidity and then proceed to building more legit projects, hopefully. So the TLDR is really just charge a certain amount of tax when your crypto or your token is being sold or transferred to somebody else. So what that does is kind of it disincentivizes selling or transferring, and it kind of incentivizes holding the token for longer periods of time, right? So it's like if I have 100 tokens, if I send them to somebody, they'll only get 90. Or if I like try to sell it for something else, I'll only be paid for like 90. And over time, kind of like if people keep holding and supply is lower than demand, there's like price goes up. That was kind of in a simpler way the whole shtick of SafeMoon, where they used to charge a massive tax every time you sold the SafeMoon token, and over time it literally just blew up. It was so expensive, and it eventually came crashing down. It is a Ponzi, but it's a little fun project, and that's all it really means. Just charge a tax every time that token is being transferred. The only requirement, if we're going to follow along, the only requirement I have is that you must have MetaMask installed. Hopefully you guys know what MetaMask is. If you don't, it is an Ethereum wallet. Just Google for sort of MetaMask. I will also share the link in chat. I believe it is metamask.io. But just sort of install MetaMask, have a wallet set up, and try to follow along and ask questions in chat if anything comes up at all. And we'll kind of go from there. Oops, this is for later. So we're going to be using a bunch of different tools. Let me know if you need me to zoom in at any point. We're going to be using a bunch of different tools sort of designed for beginners and make it easy to like start off with Ethereum coding. First things first, once you install MetaMask, go to like metamask.io, hit download, whatever. It will download as like a browser extension. So it should show up here, and follow these steps to set up your wallet. Once you've done that, I'm just going to go through like the absolute basic stuff in case this is your literal first time trying to develop on Ethereum. So once you've set up MetaMask, you're going to change a few settings to kind of turn on developer mode. So click on this like accounts thing over here at the top right, and go into settings. And within settings, go into advanced, and then scroll down all the way until you find show test networks. And you want to turn this on, okay? Because we're not going to be spending real money. So turn on show test networks so you can play around with fake ETH and fake money. Once you've turned this on, then we can kind of like start developing contracts with fake ETH. So make sure this is on. Once you have that, you'll see on the top over this networks, it should probably be defaulted to like Ethereum mainnet or something, but you'll see you'll get a bunch of new test networks over here that previously weren't visible. And for the purposes of this tutorial, we're gonna use the Goerli test network. So click here and select the Goerli test network. You'll probably have 0 ETH. I have a bunch on here, but you'll probably start off with 0. So we're going to do a little bit of a setup. So you'll start off with 0, but go to the Goerli test network. And the first thing you want to do is kind of get some Goerli ETH, right? So you can like actually make transactions on the Goerli network and whatnot. I have 5,000 Goerli. I'm a faucet myself. That's actually the point of this. I'm actually like, for Learn Web3 students, we're building like an exclusive faucet for students at Learn Web3. So I got sent these 5,000 ETH through like somebody in the Ethereum Foundation. Anyway, so we're gonna go over to this faucet. There's a bunch of faucets. You can Google for Goerli faucet, but it's very high demand. So hopefully you get lucky and you find something. I'm gonna put this link in chat again. Head over to this Chainlink faucet, and it'll ask you to like connect your wallet here. It will detect that you're on the Ethereum Goerli network. It should auto pop in your wallet address, and it will let you kind of like request a little bit of test ETH. Don't really need to care about the test link. We're not going to be using that. If you want it, go for it. If you don't want it, don't worry about it. We're not going to be using this. What we really want is just make sure you have the 0.1 test ETH checked, and you're going to do some like human verifications, log in via Twitter. Hopefully you have a Twitter. If you're not on Twitter, get on Twitter. You're in crypto now, but get on Twitter, log in, and select 0.1 test ETH, do the little CAPTCHA thing. Teacup with a similar, these keep getting harder every single time. Similar design pattern. Okay. Okay, great. And then just send a request. If you don't have a Twitter, send me your address in chat. I'll send you a little bit of ETH, but sure, I'll just send you some right now, Stephen. Just send me your address in chat. Anyway, wait for this to happen. There we go. Okay, just gonna send this guy a little bit of ETH. Oops. If anybody else needs it, they don't have Twitter or something, just let me know. This is what this ETH is for. Anyway, you should be getting it soon. We sent you 0.1. But anyway, for other people, we'll get it on the faucet. Wait for it to complete, request complete, and it should start showing up in your wallet shortly after. The 0 should change to like 0.1 or something. Once you have that, our setup is done, and we can now start actually coding. So we're going to use this thing called Remix. Remix is kind of like a code editor for building Ethereum contracts. And the good thing about Remix is that it runs in the browser, so you don't need to like, download and set up things. We're not going to get into like a local development environment for Ethereum right now. It's a great place for beginners to start. Over time, you'll find that Remix has its limitations, but for today, it is more than enough. So open up Remix, and it'll start off with like a default sort of file structure. It looks very similar to VS Code or whatever you may be used to. And this is where we'll be creating our smart contract. So I'll maybe wait a minute here just to make sure everybody's set up. If anybody still needs ETH, anybody has any questions, any problems setting up MetaMask or something, ask now or forever hold your peace, because then we're going to start coding. Oops. Okay, I shall take that as a no. Okay, so what you want to do is we're going to go into this file explorer, right? Go into contracts and create a new file over here. We're going to call it, I don't know, taxtoken.sol. So .sol is like the extension for Solidity files. And Solidity, if you don't know, is the programming language, one of the programming language used to create smart contracts on Ethereum. So name it like taxtoken.sol. And the first thing, so every Solidity file starts off with a version declaration. So you need to specify what version of Solidity you're using. And the way you do that is through writing this line of code, pragma Solidity, and then version number after that. So I would suggest let's go with, maybe this is too zoomed in. Okay. Let me see if I can just zoom in the text. Oh, perfect. So yeah, start off writing this line, pragma Solidity 0.8.13. This is, I believe, the latest Solidity version right now. I'm not sure. Oh, we're at 0.8.17. Nice. Okay, let's just use the latest version. But you have to specify what version of Solidity you're using because, you know, the blockchain is supposed to be backwards compatible. It's an immutable chain. So a contract that was deployed 5 years ago using some ancient Solidity version 0.2, 0.3 something, they have like a different way of writing things. The language got updated over time, but the blockchain still needs to support that smart contract, and that should still be functioning. So every smart contract kind of defines how to interpret my code. Like, this is the version I wrote this contract for, and this is how you interpret the code. And the Ethereum network kind of runs your contract based on that version of the language that you specified. So we're going to start off, we'll use the latest version now, 0.8.17. And every bit of code in Solidity, it's wrapped inside like a contract block. So if you've ever done any object-oriented programming, C, C++, Java, whatever, you've probably heard of classes. And the way to think about this is Solidity is also an object-oriented language, but kind of focused on contracts instead of classes. So contract is very similar to a class where it can have variables, it can have functions, yada, yada, yada. And all code needs to go inside of a contract block. I cannot write code outside the contract block. The thing we'll be using, if you've, again, how many of you here know what an ERC20 is? Or would somebody care to unmute and quickly explain what an ERC20 token is? Actually, I don't know if they can unmute. Fahim, can people unmute? I'm not sure.
Let me just quickly change that. Okay, people can unmute themselves now.
Okay, if anybody wants to quickly explain what an ERC20 is, a token that follows the ERC20 protocol. Okay, sure, but what do we mean by the ERC20 protocol? Like, what's it used for? Fungible tokens, yes. So ERC20, as Jason said, it's a standard on Ethereum for creating fungible tokens. So basically like a cryptocurrency. Most tokens on Ethereum, like they follow the ERC20 standard. Since we're creating a token ourselves, we're going to use that standard as well to make life 100 times easier for us and have a lot of things already set up and pre-built. Stephen asks, are there any globals you can set or use, or any libraries you can import, or is everything always inside a contract? So as for globals, you can have like all data is usually scoped within a contract, right? Data for your contract is stored within your contract, and then you can like have a function that returns that value or something, so other contracts can like read that value if you want. As for like overall kind of like network globals. The Ethereum network will push in some global values for every smart contract, and we'll look at a couple of examples of that. So it includes things like the block timestamp, like at what time was the transaction mined that called this function, or things like, like the message sender, like who was the person who called this function, like was the address of the person who called this function, and so on. So there's a few sort of global variables that are built into the language itself and that are provided to you, provided during execution by the network. So there's like those global variables. Other than that, all variables you define must be inside a contract block. And as for libraries you can import, actually, yes. So we're going to do that right now. Since we're going to use the ERC20 token standard, we're going to be using this library by OpenZeppelin. So OpenZeppelin is this kind of like security company for Ethereum, and they do a variety of different things. But one of the things they do is they create implementations of common sort of standards, things like ERC20, like fungible tokens, non-fungible tokens, yada, yada, yada. So OpenZeppelin creates like these standard, battle-tested, audited implementations of these things. So you can kind of like trust them and just use that implementation as a baseline for whatever you're building. So we're going to use their ERC20 contract and import it into ours. And the way to kind of do that, I'm going to share this link here as well, by the way, if anybody wants to see it themselves. But you go to their website, go to ERC20 and take this like import line. See this import line. I'm just going to copy paste it here and then explain what it means. So, I mean, this looks very similar to any import in any programming language ever. Remix is smart enough that when you add this line, in Remix, you can import files one of three ways. You can import files either by like a direct path, like if you have your own local copy of the file over here somewhere, you can import your like own like mycontract.sol file, or you can import from GitHub. So you can add like an import github.com/yada yada yada, and or you can just like import kind of like this thing, and Remix interprets this as like importing from an NPM package, like importing, like treats it like a Node.js NPM package. So we'll see if I click save, if I press like Command S on my computer on Windows, it might be Control S. So if I click save over here, I'm getting an error right now because I'm using a different compiler. I need to switch to 0.8.17. But yeah, if I click save now, it obviously we don't have any code yet, but one of the things you'll notice is after it compiles, this .deps directory will fill up. So it'll be like dependencies, npm, OpenZeppelin, contracts, token, ERC20.sol. So it kind of just like fetches that file from npm. We took a detour there. I don't know. It's not directly relevant, but it's just a cool little thing that Remix does. So you can just import things like this without copy pasting and creating those files yourself. So we're going to follow the ERC20 standard. So we're going to just say contract tax token is ERC20. And this is kind of how you do inheritance in Solidity, like a class extending a class. So it just says that this contract tax token is an ERC20 token, and then anything else is just additional code that we choose to write. So similar to classes, you can define constructors, and then you can define your own functions, and you can define your own variables and whatever. In the constructor, one thing we need to do, and let me also just open this file so you can see what I'm talking about. Let's see, ERC20.sol. So in ERC20, you'll see that this file has its own constructor. So typically, I don't know what programming language backgrounds you're coming from, but if you're extending a class that has its own constructor, you need to call that constructor within your constructor as well. So the ERC20 constructor takes two values, a name and a symbol. So this would be kind of like Ethereum and ETH. So we're going to call that constructor as part of ours. And the way to do that is just kind of like this. So we'll just say tax token TT. This is the name and this is the symbol. I don't really need to do anything. Oh, actually, one more thing we'll define is we shall define how much tax we're going to charge. So let's say we're going to charge a 10% tax. So basically, we divide whatever the value is being transferred by 10. So we'll just say uint tax divisor. Is it divisor or dividend? I'll say divisor. Tax divisor equals 10. You can like change it, right? You can change it to whatever you want, but we'll basically divide the amount that is being transferred by 10. And this is the amount we will kind of like cut from the transfer. This is the tax we take. All right. So one more thing I'll do in the constructor just for sort of testing purposes, right? Just so we can show this functionality to you is ERC20 also comes with this inbuilt function called mint. And you'll see this is an internal function, which means an external person cannot call this function themselves, but only the contract can call this function itself. But the mint takes two arguments, an address and an amount. So this is like mint this many tokens to this account. That's just like money print. It's like the federal mint. So you're just minting more tokens. So actually not within the constructor, I'll just create a public function called like mint to me, which takes an amount, and there's just like a public function, and all it does, we'll just call the internal mint function, and we'll say message.sender, amount. So this is actually an example of the global variables that Stephen was asking about earlier. Message.sender, it's a global variable injected by the Ethereum virtual machine, call it the EVM, during runtime. So when this function is being called, it's a transaction that needs to happen on the Ethereum network. And while nodes are running that transaction, right, they're executing the code to actually get the value, the EVM will inject certain global variables, message.sender being one of them. And this is the address of the person who called this function. So if I call this function, it'll be my address. If you call this function, it'll be your address, and so on. So what we're basically saying is whoever calls this function, just mint them however many tokens they want. Obviously, in real life, you'd like be paying for those tokens with ETH, or maybe do an airdrop of some sort or whatever. But this is a quick and easy way to kind of show, because this isn't the main functionality we're going after. So we'll just let anybody mint however much tokens they want, no problems at all. And we'll kind of use this for testing. Now, the main fun part about how do you actually charge a tax, and this explains a few Solidity concepts as well, is ERC20 also comes with an inbuilt transfer function. Let me try to find it. Function transfer. Yeah. So it has this inbuilt transfer function that takes a to address and an amount, and it kind of like lets people, obviously, as the name suggests, transfer tokens to other people, right? Transfer their own tokens to other people. This internally calls an internal function. That's where the main logic lives, but it's not too complicated. All it really does is change like how much balance somebody has. So it's just like the sender address has this much balance, their balance must be greater than the amount they're trying to send. If it is greater than the amount they're trying to send, then reduce their balance and increase the balance of the recipient. Fairly straightforward addition, subtraction code. Nothing too complicated going on over there. But what we're gonna do is we obviously don't want this. We don't want you to be able to send how many tokens you want. We want to charge a tax on it. So what we're gonna do is we're gonna override this function. So you'll notice that the transfer function, it's marked as virtual. And what a virtual function means is the inherited class, so like tax token inherits ERC20, an inherited a contract that inherits this contract can override this function, can change what it does. And if it doesn't override it, then we'll just use the default implementation. If it does override it, then we use that one. So basically, all we really need to do is create a function with the exact same name and the exact same arguments and just mark it as an override. So we'll say function transfer, and I believe it's to and amount. Yes. All the variables name don't matter, but the data types must be the same. So we're gonna take the address to and a value amount. This is a public function that anybody should be able to call. And this is overriding the previous declaration, and it needs to return a Boolean. That's just how the standard is. Typically, the Boolean would represent if the transfer went through or not. All right. We have to do a few different things here. First, make sure sender has enough money to send, right? Earlier it was taking care of it, but we're overriding it, so we need to do that check ourselves. So making sure that the sender has enough money to send in the first place, then take out a 10% cut from it, right? And then transfer the remaining 90% to the recipient. Okay. And then the transfer function also needs to emit a event. We don't need to go into details of what that is, but we just have to, I'll just say, we'll need this line. It's for indexing purposes, but events are something we're not going to get into today. You can learn more about it. It's irrelevant for today's tutorial. But at the end, I'm just going to make a note that even though it's not important, we need to emit the transfer event to let people know that a transfer occurred. All right, so let's start off. Let's start off doing this. So making sure the sender has enough money. The sender in this case is the person who called this function, right? Whoever called this function is trying to send tokens out of their own account. So the sender address is equal to message.sender, the global variable, right? And what we'll do is we'll fetch the balance of the sender. You balance sender equals, and again, ERC20, you can either kind of like read from this data directly. So ERC20 defines like this mapping. It's kind of like an object or a dictionary in other languages, but there's this mapping called from like an address to a number. That's just like a list. Object of balances, right? Like this address has this much tokens, this address has that much tokens. So you can either read from this mapping directly, or there's also a built-in function called just like balance of, where you just give it an account and it just returns a number. We're going to call the function just because it's a little cleaner in my opinion, but you do what you want. So we'll just do balance sender is the balance of message.sender. And we need to make sure the sender has enough money to send. And the way to do that is through require statements in Solidity. Require statements are kind of like if this, then that. It's very similar to like a conditional, but different syntax a little bit. So we'll just do require that the balance of sender is greater than or equal to the amount they're trying to send. So if this statement is true, you just move on to the next line of code. But if this statement turns out to be false, then it throws an error. And you define that error as the second argument of the require statements. You just say, like, I'll just put whatever error message you want. I'll just say ERC20, not enough balance for transfer, right? So as long as this is true, you move on. If this is false, kind of like throw an error. So Jason asks a question, does require give back the money that the function was called with? So the way it works, all transactions on Ethereum, and in fact, any blockchain, typically tend to be atomic transactions. So what that means is if at any point in the function call, there is an error, the whole thing is rolled back. Like it's always all or nothing. Either the entire function executes and all the changes that were made happen, or none of the changes happen, and it's like you never called that function in the first place. However, there is transaction fees associated with calling a transaction, right? Sending a transaction on the network. So let's say you send out let's say you're calling a function, and the way transaction fees works is the fees depends on how complex the function is. So the more lines of code, as a general rule of thumb, the longer the code and the more complex the code for a given function, the more transaction fees it will cost to call that function. And if there's an error at any point, the way to sort of mentally think about it is the nodes who were running that function on your behalf, they already spent resources, right? They spent their computational resources calling and running the code up until that point, and then there was an error, and then the function failed, right? So the transaction fees that you sent, you'll only get a partial refund back of that, because the code that was already executed, you still need to pay fees for that, even though the overall function failed. But the fees you had planned to give for the remainder of the function, you get that back. However, as for the transfer token, or do you get back the tokens you had, or things like that, they just you don't need to worry about it. Nothing is changing. Your balance remains the same. Everything remains the same. The only thing that changes is you still pay a little bit of the transaction fees, even though the transaction didn't actually work as you may have expected it to work. Sahil asks, OpenZeppelin hasn't updated their contracts, use custom errors yet. Yes, custom errors, we're not going to get into that today. This is a different way of throwing errors that's a little more optimized and costs less transaction fees. I believe the reason they haven't done that is just because it's a new feature relatively, and there's not as much support around it in the ecosystem, I think, but I think they'll eventually get around to it. You can also use, there's alternatives to OpenZeppelin, like Solmate or whatever you can use that I think have implemented it. But regardless, getting back to the point now. So yeah, so the first part is done, right? We make sure that the sender has enough money to send. Now for the second part, we take out the 10% cut, right? So we need to calculate how much money is left over after the cut has been taken out, which is 90% of the amount. Now, one thing to note is Solidity does not have support for floating point numbers, i.e., you cannot do 0.9 times amount. This will give you a compilation error, right? You cannot use decimals, you cannot use floating point numbers. And if this was a variable that somebody was passing in, the 0.9 would just be treated as a 0. You can only have integers. You cannot have floating point numbers. The reasons for this, again, are because floating point math is inaccurate. And you might have seen that sometimes 1 divided by 3 could be equal to 0.333, but 0.333 into 3 is equal to 0.999. The floating point maths is inaccurate, and this can lead to issues when we're talking about DeFi protocols handling billions of dollars of money. And if there's inaccurate calculations involved there, it can lead to losses. So we simply don't support floating point numbers at all. And everything is an integer. So we cannot do 0.9 into amount. So we need to divide amount instead. So kind of be tax amount will be equal to the amount being sent divided by 10, right? We set this variable tax divisor at top 10. So this will get the 10% tax amount, and then uint transfer amount now becomes amount minus tax amount. Okay. And this is the money that you'll actually be allowed to send out to the recipient. So the second part is done. And now to transfer the remaining 90% to the recipient, we take inspiration from the pre-built code because it's really not that different. So if you look at the pre-built transfer function, all it really does is decrease the balance of the sender and increase the balance of the recipient, right? So what we're gonna do, so for the from address, the from address as message.sender, we reduce their balance by how much money they wanted to send, but the recipient, the to address, gets their balance increased by 90% of that amount, not the overall, because we took our tax. So the discrepancy there, the 10% there, it just kind of stays in the smart contract. It doesn't go anywhere. This is just balance that has been kind of lost. Money disappeared into thin air, and somebody sent 100 tokens, but the person only got 90 tokens in their wallet. And then lastly, we emit the transfer event. We'll just copy paste this line. We don't need to worry about events just yet, but just it's something you have to do to ensure compatibility with the standard. And then we return it true because the function needs to return a Boolean to make sure, okay, if you got to this point, everything is good. Any questions up until this point? Does this code make sense, what I just wrote here? All right, I'll take that as a no. Cool. So can you explain again where the 10% goes? It doesn't really go anywhere. It's just kind of like money being destroyed, right? Because if you think about it, like it's like imagine a transaction between you and me where there's the smart contract in the middle. I take out $100 to give to you, and I pass it on to the contract, and then the contract only gives you $90, and the $10 in the middle, they just kind of like disappear. They don't go anywhere. They just like get removed from existence. So now there's less money than there used to be overall. Like there's less dollar bills floating around in the world than there were before the transaction happened. So it's just like destroyed. It's literally like setting it on fire. It's just burnt. It's gone. So it doesn't end up anywhere. It's just disappeared. Therefore, it reduces the supply. The more transactions that happen, the more the supply is reduced. And hypothetically, if the demand stays the same, the price goes up. And here's the whole Ponzi aspect of it. So just every time you try to send it to somebody, every time you try to sell this token, you're reducing the overall supply of the token in circulation. Obviously, in this case, it doesn't really matter because you can mint as many as you want. But that's just for testing purposes. In like a real quote unquote real situation, you would have like a fixed initial supply, like let's say 1 million tokens in existence. And then as transactions are happening, that supply just keeps going down and down and down. Okay, cool. So let's try to test this. I will say I did not test this code personally before. I'm just kind of doing this on the fly, so there may be issues, but bear with me, and it'll be a good debugging opportunity for everyone. But once you've written this code, if you were following along, what you want to do is in the sidebar, go to this third icon over here. This is the Solidity compiler, and just click compile tax token.sol, and we have a few errors, obviously. So I did something wrong here. Undeclared identifier doesn't understand what underscore balances is. And that is because underscore balances is a private function. Okay, the private value makes sense. So private values, we cannot access it from inherited contracts. So instead we will use the internal kind of transfer function. There is, let me see, what was the name of it? Underscore transfer. Okay, so address from, address to, but this uses the balances thing. Increase allowance. Okay. So we're gonna do a couple of things. We cannot use underscore balances here. My bad. That's why I used this above my brain fart. What we can do, however, is call the internal transfer function, this underscore transfer. So we'll call this twice. First time, call this underscore transfer, take it up from to, and amount. So the from is message.sender. The to is the given to address, and the amount is transfer amount. So this is the 90% token transfer. And to burn the remaining 10%, which is the tax amount, what you can do is you transfer the 10% amount to this thing called the null address. So I'll show you what the null address is. So if you set up MetaMask, if you've ever seen an Ethereum address, it kind of looks like this. It looks like, like 0x, A, B, C, D, E, F, yada, yada, yada. However, Ethereum has this thing called a null address, and every address is 42 characters long. So Ethereum has this thing called the null address, which is just 42 zeros, right? So 1, 2, 3, 4, 5. Let me actually show it to you. 10, 15, 20, 25, 30, 35, 40, and then 42. All right, if Etherscan wants to load, there we go. So this is the null address. And this address is not owned by any user. And it is often associated with sort of burning tokens, right? Just throwing things in the dumpster fire. This account is worth hundreds of millions of dollars, but nobody has the private key to this. It's not owned by anyone. So it's really just like garbage bin you throw your shit into and it never comes back. It's often also referred to as the black hole address because of this reason, where things go in and they never come back out. So to burn those 10% tokens, we just send it over to the null address. And the way to get it is in the to address, you can use the syntax in Solidity, so address 0, which refers to the null address, and send over the tax amount there. Fahim asks, I just realized, could this become more of a Ponzi if instead of the null address, you send it to the owner's address? Yes, and I'm 100% sure there have been projects that did that. Definitely people have done things like that where the owner of the contract just keeps getting free money, free tax over time. Typically those die off very quickly because as soon as the token's worth something, the owner would just go and dump it on the market and then it's just dead. But yes, you can do that. You can hard code your own personal address and then just send this 10% to yourself every time somebody else tries to make a transaction. That's max Ponzi. All right, let's try this again. We click compile, and this time we only have one error, which is nice. Emit transfer not found. That is okay. It is because it doesn't know what transfer is. Is ERC20. Oh, but we don't need to emit this ourselves now because we are using the internal transfer function. So it will be emitted anyway. Cool. What's the difference between the null address and the dead address? There's really not a lot of difference. For those who don't know, the dead address is also another kind of like funny little vanity address where the last 4 letters, instead of 0, they spell out the word dead. This is also commonly just used by projects to like burn tokens. The reason this kind of exists at all, why people use this at all, and why this address is also worth hundreds of millions of dollars is because certain older projects on Ethereum, actually, we might have to use this ourselves. That's a nice catch. I forgot about that. But if you look at the ERC20 implementation and the internal transfer function, you'll see it actually prevents you from sending something to the null address. And it's just like, it doesn't let you burn tokens directly. So that's actually a good catch because if we do this, this function will fail. You cannot send money to the dead address. Instead, you cannot send it to the null address, but you can send it to the dead address over here. And then that's just another way of burning tokens. This address as well is not owned by any user. It's just a funny little address that's not blocked by the most common default implementations of tokens. So a lot of projects just use this instead of trying to modify the ERC20 implementation by OpenZeppelin. Actually, yeah, that's a good point. Thank you for pointing that out. But okay, So we transfer it to the dead address, and that's where the text goes. And now if we compile, it should compile. Oh God, no. Invalid. Oh, right. You don't wrap this in strings. Addresses are not strings. They're built in to the language, and they're native data type in the language. All right, now it should work. Perfect. Compiled, no problems. I'm going to zoom out a little bit so it can give you like a little overlook of the final thing. You see my mint line. Sure. There it is. And let me just remove the comments from here so it can all show up on like a single screen share. And there you go. But if somebody creates a new account and they happen to get the dead address, it is not impossible. There is a possibility that one day somebody finds the private key to the dead address, or even the null address for that matter. However, the probability for it is extremely, extremely small, because the key space for Ethereum is well over sort of 2 to the power 256, which is an astronomically large number, very, 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 very large number. And the chances of you finding a very specific key in there is 1 over 2 to the power 256, 256, which is it's just improbable. It's not impossible. And this is true for all cryptography in the world. Cryptography is a probabilistic, cryptography by nature is probabilistic. It's not 100% guarantee. If you do find it, well, leave this workshop and go live your life, man. You're gonna be super, super rich if you do. Just be careful of the authorities. I don't know if that counts as like, I don't know how much tax you're gonna have to pay on that one day you wake up and you're suddenly $500 million richer. Jeez. Amazing. Yeah, keys.lol. A fun little website if you want to waste your time and you just want to do mindless scrolling. There's this website that just like has like random private keys and addresses showing up. You just go there and it'll just generate a bunch of private keys and addresses and then check if any of them have an actual balance. They always end up with 0 because there's just so many possibilities. The chances of you finding an actually active address are pretty much highly, highly improbable. But if you want to waste your time, just go through it and just, yeah, just mindless things. Anyway, I feel like somebody's already botting it. I'm sure they are, but like it's really not that hard. You just like write a script and this just like does an infinite for loop and just generates new private keys and addresses for Ethereum. It's just like so fucking improbable you'll actually find something. Like there's no point in botting this actual website. Just write a script yourself on your own computer that does this exact same thing. You can have it done in like less than 10 lines of code, but it's just so improbable you'll actually find something worthwhile. It's kind of useless. You'll probably die before you find something worthwhile. Anyway, let's test this out. We're closing in on time, so I'm gonna compile this. Once it's compiled, what you want to do is head over to the 4th tab in the sidebar. This is the deployment tab. Now I want to do a couple of things here. First of all, you see this environment thing. Change this environment to injected provider MetaMask. So this way, and it will probably pop open your MetaMask and ask you to connect to this website. Do that, and when you do this, what happens is like it will actually let you like deploy this contract on the actual Ethereum test network, specifically the Goerli test network that we were using, and went to the faucet for and grabbed a little bit of ETH for. So we'll actually deploy this contract on a live test network, not just a simulation. The default setting for Remix, the Remix virtual machine, this is just like a simulation of the network. It's not an actual Ethereum network. We'll get out of the simulator, we'll deploy this to the actual test network, connect to the website, and then select tax token in the contract dropdown over here and click deploy. And this should pop up on MetaMask, ask you to confirm a transaction. You're going to be paying some transaction fees. And this is what we got the tokens from the faucet for. So you can actually deploy this contract on the network. Click confirm and wait for a few seconds while this happens. Test networks can get a little busy at times. All right. I mean, think about like 10 or 15 seconds usually. All right. So once it's done, it'll show up over here under deployed contracts, and you can click on this little arrow. Oops. Sorry, my mouse gets a little funky sometimes. You can click on this little arrow and it will show you all the functions you can call in this smart contract. A lot of these are things we didn't write ourselves. They're just built into the ERC20 standards, things like the balance of an account and like a name. And you click on name, it says tax token, the symbol, TT. Total supply is currently 0. There's 0 tokens in existence, and so on. But we did create these 2 functions, mint to me, and we overrode the transfer function, right? So to test this, I'm just going to mint myself a bunch of tokens. Just going to go like 1,000 tokens, let's say, and click mint. This will pop up MetaMask again for another transaction. Click confirm, wait for a few seconds for the transaction to go through. And in the meantime, what you want to do is there's, especially on test networks, there's millions of people, millions of ERC20 smart contracts deployed on test networks, right? People just experimenting with things and whatnot. So MetaMask doesn't have the capability to automatically just recognize random token contracts. They do that on mainnet for some of the more popular ones, where they automatically just see if you have a greater than 0 balance for any of the well-known sort of tokens. But on testnet, they're not going to be doing that. There's millions of them, and it's just kind of a waste of time and resources. So you're going to actually have to add this token into your MetaMask manually, because otherwise it just won't show up. What you want to do is click this copy button over here next to your deployed contract. This will copy your smart contract's address, and then go into MetaMask. And on the assets tab, click this import tokens button, right? Click import tokens, copy paste your address. You should be able to fetch the token symbol and everything automatically, and just click add custom token. All right. Oh, I got a very tiny amount. It's actually because this is represented in the smallest unit that possible. So quick little detour here just to explain what it is. Since Solidity doesn't have support for floating point numbers, and you cannot have like 0.0001 of something, the way decimals work, the way you're able to own 0.1 ETH or 0.0001 ETH or whatever, is that it treats it like an integer, but it kind of like pushes back the decimal point. So this is like the same way that $1 might be represented as 100 cents instead of $1. And this makes it easier when you want to represent things like $0.33, you just call it 33 cents. And you can deal with integers all the way without getting into floating points territory. So on Ethereum, and for all ERC20 tokens in general, the default setting is the smallest unit possible is like 18 decimal points, like 1 into 10 to the power negative 18. So the smallest unit possible is like 17 zeros and then a 1. I wasn't counting this. I don't know how many zeros I wrote here, but the smallest unit possible is that, and that amount is equal to like 1 token. There's this fun little website, like helpful little website called ethconverter.com, where you can go and say like one way, this is equal to this much ETH, and that is represented as the number 1. This is the smallest unit possible of ETH that somebody can own. So if I actually want to get 1,000 tokens, like 1,000 full tokens, I need to multiply 1000 by 10 to the power 18. And this is how many tokens I'm going to need to mint. I'm going to put it in chat if anybody just wants to copy paste this number. But this is how many tokens I'm going to have to mint for it to show up as 1000 tokens, because we're talking about it in smallest unit possible terms. Again, wait for it to go through. At this point, since MetaMask is now tracking this asset for me, since I added over here, currently I have a very small amount of it, but it will show up and I should have 1000 full tokens. All right. I think it went through. Yes. You see my balance now is like 1000 dot this 0, 0, 0, 0, and there's a 1 at the end somewhere. This is how much TT I have now. And let me try to transfer it. Let's see. I'll just transfer it to one of my other accounts. I just copy an address of some other random account I have. All right. And then shift back to this one. And in transfer, I'll send them, let's say I send them this entire thing. I send them the whole 1000 tokens. And again, it's represented as 1000 into 10 to the power 18. So I send them the whole 1000 tokens and see how much they get. They click on transact, right? Confirm this transaction. And in my other account, again, MetaMask is not tracking this token for the other account. So I'm just going to do the same steps as before. Just copy the contract address and then import it here so it tracks the balance for this token. Currently, I have 0 while we wait for the transaction to go through. And I'll wait a little while. I see I got 900. I got 900, even though I sent 1000, I got a 900 here. But if I look back to the original account, I came down to like 0 and the point small amount I accidentally added the first time around. So the 100 tokens in the middle were just gone. You can actually look at where they were gone. If you click on this transaction where you actually sent the 1000 TT, you click on view on Block Explorer. This will open up the Explorer and you can see that there were 2 token transfer events that happened as part of that function call. One of them was for 900 tokens being transferred to my other account, and the other one was for 100 tokens being transferred to this dead address. So the dead address is now the owner of those 100 tax tokens, and nobody can do anything about it. It's basically as good as just being gone forever. All right, we're at time and the demo is complete. So the tax token works. You can change this amount to charge different amounts however you want. What happens if you try to send an amount which is not fully divisible by 10? For example, just sending 85 way. So in Solidity, since there's no support for floating point numbers, if you do 85 by 10, it will just equal 8. It gets rid of the decimal portion. So the recipient will just receive 8 tokens. The tax amount will be 8 instead of 8.5, since there's no support for decimals. Yeah. Okay. So this all works. That's great. So in that case, the tax is 20%. It's not really 20%. 8.5 to 8 isn't a 10% increase, but it's a little higher than 10%. Yes, because the 0.5 got kind of ignored. Well, it's actually, sorry, it's a little lower than 10% because you're charging less tax than you would have if you had support for floating points. Anyway, all this is good. Let's go back. I mean, well, this is done. Q&A, end of presentation. Any questions, happy to answer. I'm here listening, looking at the chat for a few minutes. Last thing I'm gonna say is just that if you want more, join Learn Web3. We have over 50,000 other students learning from there. It's all free. We don't charge for courses. We don't charge for education. So come check us out. The links are here, learnweb3.io. Join us on Discord, follow us on Twitter, whatever. I'll see you there. Hope to see you there. And yeah, thank you so much, everyone, for coming. I'll stick around for any questions, but I'll stop sharing. Actually, I'll just put these links in chat and then stop sharing my screen so you can see a human face. There we go. And all right, cool. I'll stay around maybe like 2 more minutes, but if there's no questions, then we can end this. Hopefully you enjoyed, and thank you again, everyone, for coming. Best workshop one. Thanks, man. I appreciate it. We hope the Web3 needs more devs. I hope you guys join. And yeah, I'll hope to see you around the Learn Web3 Discord and everything. All right, looks like most people left. Doesn't seem like there's any major questions. So Fahim, all right.
We can wrap it up. Thank you so much, Hardik. That was the best workshop I've followed along, and really looking forward to more collaborations in the future.
That's awesome, man. Thank you so much. I'm glad to hear that. Yeah, I'm gonna